AP Calculus AB. This is a sample question. I think this is from the 2002 exam. So we have this graph here where we have f of x is equal to e to the x and g of x is equal to ln of x. And we're asked right here to find the area of the graph bounded by f and g between 1/2 and 1. So this is what I'm looking at here. As I look at this graph, this is not my exact drawing, but like, you know what, this is the area I'm looking at. Let's let this line be x is equal to 1/2. So 1/2 to 1. So we're looking for this area right in here. So I think this is actually pretty simple. This is on a calculator section. This is on a calculator section. So remember, all we have to do is this. We know that area is equal to the definite integral a to b of f of x minus g of x dx. This is a calculator section, so it's really important here to kind of document or show your analysis. So this is me showing my analysis a little bit, and I'm saying that that gives us this. Remember that this f of x has got to be the top function, and this has to be the bottom function. And if they switch, if sometimes it's the bottom, sometimes it's the top, you have to integrate on as many parts as it takes to get that correct. But in this case, we see here that the e to the x function is on top the whole time, and this part is on the bottom the whole time. So we're looking for this area right in here, aren't we? So this is the area that we're looking for. So this is actually just this simple. So this is, therefore, area is equal to, and they give this to us, 1/2 to 1. So 1/2, the lower bound, to 1 of f of x, which is the top. Well, it's e to the x minus the one that's on the bottom, and it's ln of x, so ln of x dx. We don't have to do any more arithmetic here. We can put this right into our calculator. Do this carefully. And remember to use the approximation sign. So I'm going to say the area is approximately equal to, because it doesn't work out perfectly, to about 1.222. And they don't give us any units. If they did give us units, I would take that as units squared. So there's that part. That's what I'm going to do first. So this is our first answer. And then the other thing, this is really important, you guys, is after you finish this thing, check it off on your paper. I did that. So you can look back at the end and say, I did all those pieces. So this is section A, so I did section A. And I'm going to move on to section B. And section B says, find the volume of the solid generated when the region enclosed by the graphs of f and g between 1/2 and 1 is rotated about y is equal to 4. So have B, part B. We know also, right, that we have volume here. We have volume here, and that volume is going to do this. We know that volume is equal to pi times the definite integral of, we do this, rx squared minus little rx squared dx, right? Where this is larger, and this is smaller, or inside piece here, right? So I'm just going to look at that. I'm just going to take a quick look at that. And the volume is going to be this, right? Here's the line 1, 2, 3, 4. So it's going to be rotated about this line right here. It's going to be rotated about this line right here. Right, and it's going to be going this way, right? It's going to be going like that, around that line. That's good news for us. And then we're just going to find, well, what's the radius of each piece? Well, the outside piece, the piece farthest from this, is the ln. So and this is 4, right? So I'm going to take this as this. Take this as the outside piece. I'm going to take this as. So the volume of the area of the specific region I'm looking for is 4 minus ln x squared minus, and what's the radius of the outside piece? I'm sorry, the inside piece, that's the blue piece right here, should be 4 minus e to the x, shouldn't it? Squared, right? So 4 minus e to the x squared. Remember, this square and this square come from this formula, right? And then I'm going to put all this to dx. From here, this is the analysis that they're looking for, and we have to be careful to give them our full analysis because they're going to give us a point for all these little pieces. They're going to give us a point for setting up the integrand correctly. So here, this is correct. This is the correct formula. So out of the 3 points I can get here, I have, actually this is 4 points. This is actually, you can get 4 points for this question right here. So have all of that, and now I'm going to put this into my calculator, and I'm going to get that volume is equal to, remember to keep track of this pi value out here, because if you just take this whole thing like this and forget the pi value, it's going to come out wrong. So it comes out to be, is it 7.515? So 7.515 pi. Again, they don't give us the units. I'm going to also put this approximately again. Or you might have gotten a different answer and say that this is approximately equal to 23.609, I guess, is a possibility. All right? So be careful. Remember, show your calculus. Show your calc. I have had a lot of really, really smart students that they know the answer, and they know how to get to this. And I tell you what, out of the 4, I'm looking at this thing here, out of the 4 points possible for this question, 1 point is for the limits and the constant. The second, you get 2 points for the integrand, right? And you have to set it, so we have, and then we have to set this thing up, so we get a point for setting that up, and then we get only 1 point. So out of 4 points, only 1 point for the answer. So having the answer sucks. Just the answer itself sucks. You can still get 3/4 of your points and get the wrong answer. So remember that. Conversely, you can get the answer alone correct and show no work and get only 1 of 4 possible points. So remember, we have to play this game with some strategy, don't you? All right, let's see if we have time to look at this last piece right here. It says let h be the function given by h of x is equal to f of x minus g of x. And we want the absolute minimum value of that. So the way I think I'm going to do this is this. We want minimum value. So I think what I'm going to do for part C, well, you know what I said? I said I should check this thing off. So check this off. We did this. So let's move on to part C. So part C, I'm going to find this absolute. So what I'm going to do is this. I'm going to find, for C, I'm going to find, say that h prime at x, because that's how we find minimums and maximums, isn't it? Is f prime at x minus g prime at x. This is just the sum and difference rule, isn't it? So I'm telling my reader that I know what I'm talking about here, and I'm going to say, therefore, I'm going to do this. I'm going to say that h prime at x is equal to, right? So h prime at x is equal to, well, what's the first derivative of e to the x? And the first derivative of e to the x is e to the x, right? Minus, what's the first derivative of ln of x? It's just 1 over x, isn't it? And then I'm going to set that thing equal to 0, because we know that this is slope, and when slope gets to 0, we have potential for a minimum or a maximum, right? So I'm going to just put this into the calculator, right? Going to ask the calculator this question, solve this. Hopefully you're using a ti-nspire cast, and if you're not, please let me know so we can talk about that. But I want to solve for when this equals 0 using your calculator, and your calculator should give you x is about equal to 0.567. And I wouldn't round this very much here, because this is going to come in really, really handy, right? So then what you want to do is just test the outsides, right? The outside parts and where the slope goes to 0. So the first outside part is f of 0.5, f of 1/2, right? That's this half right here, right? F of 1/2, and f of 1/2 is equal to 2.3418. This is kind of important here, right? And then I'm going to take f of this number that we found. So f of 0.567143 is equal to 2.3418. Oh, no, it's 2.330. 2.330. So I'm looking for minimums and maximums. And then lastly, remember, just so you know where I'm getting these numbers from, I'm going to take, this is the outer part, isn't it? So I'm going to take, well, what's the height at f of 1? And f of 1 is 2.718. So hopefully we can see this. So we're going to write this. Pick the smallest number. So we can say absolute min is 2.330 at x is equal to 0.56714. Whoa, yeah, 143, right? 143 there. And then absolute max is 2.718, isn't it? Is 2.718 at x is equal to 1. All right? So this is what my math would look like. This is what they care about. You're going to get tempted not to show all this. And I'm telling you right now, this is a 3-point question, and you only get 1 point of the 3 points. You only get 1 point for the final answer. So all of this is all your analysis is the bulk of the points that you're going to receive. Hey, you guys, I hope this was really, really helpful for you. I really do. If you have questions or comments, please let me know. And if you haven't already subscribed, please subscribe. Thanks, you guys.